All right, so you guys had a little time to answer the questions on the warm-up. Okay, so we're looking here at this parabola, and can anyone tell me what the vertex is?
0, -3.
0, -3. Good, good. And what is it that you're looking for to find the vertex? Like if you wanted to, if you're describing it to somebody, like what would you say?
You're looking at the axis.
See, you are actually looking at the axis of symmetry because the vertex and the AOS have a direct connection. But like, let's say I had no idea about this, and let's say let's say you're telling it to your parents or something like, and they ask you what the vertex is, and you're trying to explain to them where to find it on this graph. What would you tell them?
You're looking at the U.
Looking at the U, okay. So I mean, really, kind of what the way I would describe it is, I would say, well, it's where it transitions. So like if you're following this from the left to the right, it's going down, and then here's the transition spot where it goes back up, right? So it's that transitionary spot right there where it goes from down to up. Or it would be, if it was opening down, it would be from going up and then transitions back down. It's that right before that transition. Okay, the AOS. Who could tell me what the AOS is? Axis. What is it?
-3.
Wouldn't be -3. Remember, it's the vertical line. It's the equation for that vertical line. So it's a line that goes up and down that cuts this in half. That cuts the parabola in half. What would that be? Because -3 would be right there. That would be x equals -3 right there. That's x equals -3. Okay, it's right in the middle. It's actually x equals 0. And see, there it is, that gray line. There's that gray line. Dash line's hard to see because it's right on the y-axis. But the equation of that line is x equals 0. The equation for the AOS will always start with x equals. Always x equals. Because that's a vertical line, and that's the properties of a vertical line. Okay, does this parabola open up or down?
Up.
Opens up. So because it opens up, does this graph have a maximum or a minimum?
Minimum.
It has a minimum because it's at the bottom of the graph. Exactly. So all graphs that open up have a minimum. All right, any questions with these? Anybody get them all right? All 4 correct? Not one person? Not one person? So this stuff is that challenging? That hard, huh? All right. I guess we need more practice there. All right, so go ahead and go back to Classroom and open up the lesson 2. Open up the notes. Oh, look at Alexa heard me. Alexa, stop. It's funny. She played some station or whatever. It's funny. All right, Caleb, we'll look at it on this next. I'll explain it on this next one, okay? All right, does everyone have it open? Lesson 2 notes? All right, make sure you guys are taking notes. You're going to end up submitting. That's how I'm going to take a roll. All right, so the objective is wrong. All right, really what we're going to be doing is we're going to be looking at equations in the form Oops, let me go back real fast. In the form y equals ax squared, and we're going to look at what happens if we change that a value. What happens if we make that number a positive, a negative, a fraction, whatever? How is that going to affect the graph? Okay, so let's take a look. All right, so we learned that, remember the quadratic, all quadratics have a parent function that's y equals x squared. Okay, that's the parent function. That's the stripped down version. There's nothing happening to it. There's no translations or transformations. Okay, and here's the graph. Here's what it looks like. Okay, vertex. Remember the vertex is here at the tip, right? It's always that bottom, or if it opens down, it's that top part. So it's that spot right there, right in the center there. And that vertex is 0, 0, because that's the coordinate, is the origin 0, 0. The AOS, or axis of symmetry, that splits your graph in half. You drew a line right in the halfway point, and then remember the AOS always goes through the vertex. The AOS on the parent function is x equals 0, just like on the warm-up. Okay, this graph, because remember it's positive here, it opens up, and because it opens up, it has a minimum, right? Because it's at the bottom of your graph. It's at the very bottom. Your graph never goes below that point. Now, what do you think would happen, or what do you think the graph of f of x equals 3x squared would look like? What do you think this 3 would be? So first, let's look at the parent function. Okay, who could tell me what that number is in front of x squared? What's my a value here in front of x squared? What's hidden, that's invisible, that we don't write? That's implied right there.
1.
There's a hidden 1. Good, there's a hidden 1. Now, if I change that 1 to a 3, what do you think is going to happen to that? Just take a guess. Anybody? So nobody can think of anything of what that 3 would do.
I think the U would be higher.
So you think it's going to bring the graph up? Is that what you think? Okay, that's a good. And actually, period 2 said the same thing, but
Would it go down because it's positive?
no. Usually positive numbers go up, because even this number right here in front is a 1, and that's a positive 1, so it's actually going up. Okay, so these are all good guesses. Okay, I'm glad you guys are putting in some input here. Okay, but what happens here is this 3, it's going to make your graph steep. It's going to make it skinny. Okay, so the parent function has this pattern. Watch this pattern. Watch. I'm going to go back one. If you go over 1, it goes up 1. You go over 1 again, it goes up 3. You go over 1 again, it goes up 5. That's true for the parent function. So that means you'd have to multiply everything by 3. So if you go over 1 instead of up 1, you'd go over 1 up 3. And then it was over 1 up 3, but it's going to be over 1 up 9, because you multiply the 1, 3, 5, 7 by 3. So it actually gets steeper because it's going up faster. Okay, so if you can, when you draw this in, maybe make the color different. Make it like the same color as this. Try to make it like a purplish, so that way you know which graph is which. Okay, so it's made it steeper. All right, so let's explore that for a little bit. Okay, and you don't have to draw this perfectly. Just draw it skinnier than the blue one. That's all you got to do. It's fine. Okay, so let's discuss on how the a value affects the graph. That's our goal for today, is just looking at a number in front of x squared. Okay, so what is the value of a in the parent function? We actually just talked about that, right? Remember there's a hidden 1 there. We don't ever write it. We don't write it. We just say, oh, x squared, and then everybody's just supposed to know, hey, there's a hidden 1 there, okay? So there's my parent function. There it is, graphed. So let's graph a couple other ones. So we've actually already graphed this one, this 3x squared. And remember, it made it nice and tight, skinny, okay? So now what do you think is going to happen with this one? So this 0.5x squared. So we went from 1 to 3, and it made it skinny. Now we're going from 1 to 0.5. So we're always going back and comparing with the parent function. We're going to be doing this a lot. All right, so you guys need to know what the parent function looks like, and everything compares to that parent function. So what do you think 0.5 is going to look like? 0.5x squared compared to 1x squared. Any ideas?
More skinnier?
Oh, so you think it's going to get ultra skinny?
Yeah.
Okay. Okay, anybody else? Okay, check it out. Here's the graph. Tell me if it surprises you or not. Does that surprise you guys? Was that
Yeah.
It was? Okay. So here's the rule here. So if the number is bigger than 1, it's going to get skinny. So the bigger this number is, the tighter and skinnier it is. The smaller the number is, the wider it gets. So if this was 0.1, it would have been real wide. 0.001, we're talking about super wide. Okay, so try to color coordinate your graph so you know it's what on your notes. Any questions so far?
Mr. Six.
Yeah.
How do you know like what line, like how to graph it? Like I don't understand how you knew what to put for 3x squared.
For 3x squared, just don't worry about the graph. You don't have to graph it perfectly. Just make it skinnier than the blue one. That's really all you guys need to know, is that it's skinnier. And then the 0.5 x squared is that it's wider. Okay. You don't worry about graphing it perfectly. Don't worry about that. All right? Does that answer your question?
Yeah.
Okay. So remember, we're always comparing with the parent function. Okay. So don't, on this next one here. Oh, okay. That's right. I put this in there. So the vertex on all 3 graphs is 0, 0, right? The vertex did not change on all those graphs. Did not change. Also, the AOS is x equals 0 for all those. So a number in front of x squared does not move your graph in any way. All it does is just pushes it together or pulls it apart, makes it wider or skinnier. That's all it does. Okay. And I think it was either Hannah or Jackie. One of you said that when we had the number in front, the 3, you thought it was going to move up 3. Okay. That doesn't happen with that number in front of x squared. It does happen, and we'll see that later in the next topic. You guys will see that how to bring the graph up or down. Okay.
I'm good, bro.
All right. So on this one, all my stuff erased. Okay. Don't worry about drawing the parabola. We'll just describe down here. So what will the graph of 2x squared look like compared to this parent function? What's it going to look like? Is it going to be skinnier or is it going to be wider?
Skinnier?
It's going to be skinnier. Not as skinny as 3x squared, right? But it's going to be skinnier than the parent function. So 3x squared is actually skinnier than 2x squared. And like 5x squared would be even more skinny. So the bigger the a value is, the skinnier it is. So just write down here, just write it will be skinnier. Okay? Don't worry about graphing it because you guys already have 3 graphs there. No need to put a 4th one in. It'll just make things more confusing when you look at it. Okay, and there it is. It's just a little bit skinnier. All right, so we've looked at these a values, but what you notice about all my a values, they're all positive. All my a values are positive. So now let's look at a values. Let's look at the a values with if they're negative. Okay, we've actually talked about this already, even though we've only had one lesson on parabolas. But I've talked about opening up and opening down and why they open up or down. Okay, so here's my parent function. And let's say I make this 1 a negative, right? Because remember, negative x squared is negative 1x squared. There's a hidden 1 there. So all I did was just put a negative in front of that 1 of my parent function. How is that going to compare to this blue parabola? No thoughts?
Would be down.
It'd be down. Now, what about the width? Will that change? It won't. No, it won't change. It'll be the exact same graph, only reflected over the x-axis. That's all. It's just an open down. It's the same width because it has the same number in front, because really all we care about is the number and not the actual sign. So this is a 1 and this is a 1. The negative just flips it down, just reflects it. Okay? So here was that graph of 0.5x squared. Remember that 0.5x squared? It was nice and wide because that number's small. So if we do negative 0.5x squared, it's going to have the exact same width, only it's going to be reflected downwards. All right, so we don't look at this sign here. We look at the number to determine the number itself without the sign, which we would say the absolute value of that number, to determine how wide it is. And then the sign tells us if it opens up or if it opens down. Okay? So really, that's all we got to remember. Bigger the number, the skinnier. Smaller the number, the wider. Positives open up, negatives open down. Okay? So on your notes, I left a couple lines there for you. I want you to type in, so put like a little text input and type in what does the a value do. Type in what we just explored, and I just actually gave a rundown in my own words of how a affects your graph, which is just a in front of x squared. Okay, type it in. I'm going to look at that when you guys submit your notes. Give you some time on that. Okay. Everybody have time to type something in? Anyone want to share what they wrote? No? Nobody wants to share what they wrote in there? About how the A affects the graph?
I said the A value determines if the shape of the graph is going to be steep, skinny, or wider. Basically, how it transitions.
Ooh, nice. Jackie, very good. Did you say anything about it being positive or negative?
Yeah, kind of.
Okay. Yeah, make sure you guys mention something that if when A is positive, it opens up. When A is negative, it opens down. And then you can always refer back to these um, if you need to for reference. Cool. Good job, Jackie. Thanks for sharing. All right. So then let's look at some questions in regarding to this A value. So basically we have this parent function. It's graphed. It's color coordinated. It's the blue. And then we have a second quadratic function. And we're naming it G because you can't have the same letter. And since this is F, we have to name this something else. So we name it G. And if Mr. Sexton was a function, he would be G. Yeah. But we don't give you the A value. We say, hey, it's just AX squared. It could be some A. And it's graphed here. What conclusion, what can we say about this A value? Because of this graph compared to the parent function. Okay. So just to help you, because it's, I mean, these answers here are real mathy. All right. So A is less than 1. So we're saying A is smaller than 1. That's what that means. A is less than negative 1. So that's, no, I'm sorry, this is greater than 1. My apologies here. So that should be greater. So bigger than 1. A is less than negative 1. So we say smaller than negative 1. This here, A is between negative 1 and 0. So just right in between. So the same thing here. A is between 0 and 1. Okay? So let's try breaking it down. All right? So first thing, since my graph of G, this is G of X right there, that's G of X. Since G of X is opening down, what do we know about A? if it opens down, what can we say about the value of A?
That is negative.
Okay, so we know A is negative. So A is negative. So can we eliminate any of these options just by knowing A is negative? Are there any of these options that are not negative?
The first one.
The first one being bigger than 1, so that's impossible. Is that it?
And D.
And D, that's right, because between 0 and 1, that's still positive. Might be a fraction or a decimal, but it's still positive. So we're between B and C now. So compared to the blue, compared to the parent function, which of course is f of x, it's wider. So what do we know about it if it's wider? Is that number supposed to be like a big number where we don't care about if it's negative or positive because we already know it's negative? Is it going to be a bigger number or a smaller number to make it wide?
Small.
It needs to be small. It needs to be a decimal. And what type of numbers are small decimals?
0.5, 0.4.
Right. So they're basically numbers between 0 and 1, right? So, but the thing is, because my A is negative, we know it has to be between 0 and negative 1. That's what changes it. That's what makes this one a little bit more confusing. But here, if we said A is less than negative 1, well, if you did a number line, right, and this is 0, this is negative 1, this is negative 2, this is 1, this is 2. So smaller than negative 1 is all these numbers. So all of these numbers like this. So like negative 2, negative 3, negative 4. Well, we know if A was 2, it would be really skinny, or 3, or 4, or 5, and the negative just flips it down. So these answers would all be opening down, but really skinny. So it needs to be a decimal. It needs to be between 0 and 1, but we add that negative to it because it opens down. Okay, so my answer is going to be C on that. Okay, and that's a book question right there. So hopefully you guys were able to, at least in your heads, boil it down to B and C. So if I made this graph skinnier, but still opening down, the answer would be B. All right, any questions on that? Okay. So the important part about this question is knowing that we're in this form. We're using f of x equals ax squared. There's nothing past it. Like if we did something like this, where we put like a plus a number, like some sort of other number, like plus b or something like that, then we can't. Then this will change. These answers will be different. Okay, so we're only talking about adding an a to x squared. That's all we're talking about. Okay, and we're looking at, is it always true, sometimes true, or never true? So think about the graphs that we saw today. Okay, so if you make the a, you change the a value. Will that change the vertex? So the vertex is 0, 0. Is that always true, sometimes true, or never true for these type of equations?
Always true.
It's always true, as long as we're only talking about that a value and nothing else. Okay, and this is a book style question too. I don't think it's the best, because when we start seeing other quadratics, we'll see that does change. but there's more things to it. But we're just talking about this A. Okay? The graph opens up. I'm sorry, the graph opens down. Is it always true, sometimes true, or never true?
Sometimes.
Sometimes. Good job. The graph has a maximum. Always, sometimes, or never.
Sometimes.
Only sometimes. There's a connection here. The way the graph opens depicts if it's a maximum. So if it opens down sometimes, then it has a maximum sometimes. And then the AOS is x equals 0.
Always.
Always. Good job, Hannah. Always true. All right. I mean, we have seen some graphs where the AOS is different, but those are graphs of functions that have other stuff going on besides just the A value. We're talking about only an A value affecting it. All right, good. So these are the type of questions you would see in like the Savas Realize assignment. Cool. All right, any questions there? Okay.